Hi, my name is Rizky Abraham, and this is my final presentation for BYUI CIT 260. First, I'm going to explain about static variable versus non-static variable. Static variable in Java is a variable which belongs to the class and initialized only once at the start of the execution. These variables will be initialized first before the initialization of any instance variables. When an object is declared, no copy of static variable is made. Static variable is a variable which belongs to the class and not to the object or instance. Meanwhile, non-static variables belong to the object. A static variable can be accessed directly by the class name and does not need any object. An object does not need to be instantiated first to use static variable. It means that this variable can be used without having to create a new object for the class. A single copy of static variable is to be shared by all instances of the class. One common use of static is to create a constant value that's attached to a class. Since static variable belongs to the class, we can call the variable by using this syntax. Class name dot variable name. Compared to a non-static variable, we have to instantiate or create a new object first to be able to use it. Variable declared as static is basically a global variable. I will give you an example how to call a static function in our game. I will try to call the error view display function, which is a static function. It says right here, and it requires two parameters, which is a class name, which is a string type, and an error message, which is also a string type. To call the static function, all we need to do is just to call the function class, which is error view, and call the name of the function, which is display. The syntax would be something like this. So in this game, we're trying to perform load for the game. We have the method right here, and we're gonna wrap it with try and catch. And we're gonna catch the null pointer exception, and when it catches the error, you're gonna display the error loading file right here. And since we're gonna call the display method from error view, so we'll put the error view class display method, and it remember it needs two parameters, which is name of the class and the string of the error message is going to display. And if I want to call a non-static function, in this case, for example, a new game view, it's not a static function, I have to instantiate a new object first. For example, if I want to call it new game view, I have to create a new game view variable by calling the class name and create a new variable which is called new game view and instantiate it with new and call the method's name. So in this example, in the game controller, I'm trying to call the display method of the new game view. So I have to instantiate it by creating a new variable and call the put a keyword new. And next, I will explain how or when to use array list versus enum. Array is used when the length of the list is fixed, and you may want to dynamically change the items in the list. All of the items in the list must be of the same data type. And enum is used when the length of the list is fixed, and the items in the list will be constant and not change. All of the items in the list must be of the same data type. Array list is used when you need to add or remove objects from the list, or the objects in the list needs to be of the different data types. So the first example about the array, here in the player.java, we need to generate inventory for each character options, and we will use an array of 4 integer number for each item category, since we only have 4 categories of items, so an array of 4 numbers is required. So we have like the first category is medicine, food, and parts, and ammunition. So if you go to the banker character option, it has an array of 4 integer, which is 5, 5, 5, and 5. The method will loop through each number and generate item for each category, such as food, medicine, and such. And in this game we use array lists for our inventory, since Player can collect, buy, sell, or drop their items, so the length needs to be dynamic. For this purpose, array list is required. For example, in the shopkeeper menu, player is able to buy and sell items, so implementing array list in this case would be the best. And in our game, we don't use enum list. For the assignment purpose, our team created an enum list of the characters. And these characters, which is we call banker, blacksmith, carpenter, and farmer, share the same parameters, which is name, which is a string type, sick, which is boolean, stamina, number of items, player class, health points, and is what if the wagon is broken. We call it the parable is wagon broken. The length is fixed, and the items in the list will be constant and not change. And now I'm going to explain about the basic for statement. Basic for statement is more compact compared to the for loop, and make the loops easier to read. For example, I try to print or display every inventory item that the player has. I will create a variable called item, which is an item type, and it will go through each player items. In this case, it will go through an array list of player items. So, for example, in this case, in the shopkeeper controller.java, we have the basic for statement right here, and I have an array. I create an array right here. It's calling the player inventory items, which is an array list. So I'm gonna create a variable. I call it an item, which is an item type, and then the for statement will loop through each item list until and it's the incrementation right here. It will loop until the end of the list. And now I'm going to explain about catching custom runtime error. First thing we need to do, we need to create a custom exception class, and it needs to inherit from exception class. And the name of the class should always end with word exception. This is a convention used by programmers to help them identify the class of a runtime error. In this example, we extended the exception class because we want programmers to deal with this exception in their code. And to detect and throw a custom exception, we must write a custom code to detect the condition or conditions in your program when a program-specific runtime error. When a specific error does occur in your program, you must create a new object instance of the appropriate custom exception class and then throw the exception using the throw keyword. The throw statement tells Java to signal that the error occurred and to propagate the runtime error up to the method that will handle the error with try and catch statement. And here's this syntax. So in this example, we use the create an exception for the broken wagon controller. So we put a name, create a new class, which is broken wagon exception, and which extends the exception. And then we create the constructor. We just select everything and click generate. And here in the broken wagon.java, the fix method, we're gonna throw the propagate the broken wagon exception. So we put the throws exception right here, and then we use an if statement, and we throw the broken wagon exception object using the throw statement. Then also we need to wrap the method in the calling hierarchy that will catch and handle the error. And in this case, it will be in the do action and broken wagon view. So we wrap these method that we're calling with try and catch. So in this case, it will call the try to call the do the broken wagon fix method, and then it will catch the broken wagon exception, propagate the exception from broken wagon exception, and if it's catching an error, it will display the error, and then we'll call the error display method, and then It will catch also the number format exception, and then when it catches the exception, it will also output the display the error view display, and then call the output the an error message right here. Now I'm going to explain about byte streams versus character streams. So Java initially only supported byte file streams. Byte file streams reads and writes binary data 1 byte at a time in sequential order. Byte file streams must be used to read and write binary data. They may also be used to write and write character data stored in ASCII format. ASCII maps each character to a single byte of integer number in memory. And ASCII only supports Western-based languages such as English, French, German, and Spanish. But Java now uses the Unicode as the default format for storing character data. So Unicode supports all languages, not just Western languages. And its Unicode character uses 2 bytes of memory. So you cannot use a byte file stream to read and write Unicode character data, because byte streams can only read and write 1 byte of data at a time. So Java added character file stream classes in later release to specifically address this problem. Character streams allow you to read and write character data regardless of the format of the data. It supports character in both ASCII and Unicode format. Java recommends using character streams for reading and writing all character data. For example, you should use a character output stream class to print a report to the console, a text file, or to paper. The character stream automatically allows us to read and write data character by character. Meanwhile, byte streams process data byte by byte, which is 8 bits. So when to use character stream over byte stream? In Java, characters are stored using Unicode conventions, so character stream is useful when we want to process text files. These text files can be processed character by character, and the character size is typically 16 bits. And when to use byte stream over character stream? Byte-oriented reads byte by byte. Byte stream is suitable for processing raw data like binary files. Now I'm going to explain about how to write character data to an external file. In this case, I'm going to use a buffered writer and file writer. In this case, a player will be able to log their stats, the stats of players such as player class, type, money, health, stamina, speed, and wagon. So we have to declare the file variables first, which is I'm going to call the file writer and buffered writer, and then we're going to initialize the file variables over here, and then we're going to wrap it with a try clause, and then we have creating an array list of the stats of player, and then we're going to use a separator, which is just like an outputting a new line to the txt file, and then we're going to use the basic for loop to loop through each one of the array list, and then we're gonna write the output to the file with the buffered writer that we just created right there. And we use a runtime and process error, so whenever the player logs their stats, the program will open Notepad and output the stat just like this one. And also we catch an error, and we're going to display the error message right here. And then the last thing you should always do when reading or writing data is close the file stream. And the stream file stream is closed in the final block of try and catch statement, and we have right here. Alright, so I'm going to walk you through a little bit about the game. Here's the game start menu, so I'll put start. I'll name my character. I'll choose the class. And then this is the shopkeeper menu. You can buy, sell, and rob. And I would just go exit the store and go to the event out of town, and we'll encounter some events like broken wagon, this is contraction, and such. So we're gonna leave town, and we're gonna start another adventure. So press continue right here. It says I fall ill, I have to take my medicine. I press continue. It's going to generate a random event again. Continue, and there we go. So there we go. If the player reach a progression of 25 out of 25, you'll win the game.